Hi, my name is Ben, and welcome to this guide for your PDUS210 ultrasonic driver. By the end of this video, you will have hopefully connected your PDUS210 to your computer, updated the firmware, used the assistant to find and track a resonance, gained an understanding of the desktop software's controls and measurements. First off, we'll go over the basic connections. The power supply should be connected to the back of the unit. The output needs to be connected to a load, and for this example, I will be using an ideal test load, and the amplifier will be connected to the PC via the USB. For the time being, we'll leave the USB unconnected from the PC. The PC should have the Ultrasonic driver software downloaded from the PiezoDrive website and unpacked and open. For the first connection, it is recommended that the amplifier be powered and turned on before plugging into the PC. So let's go ahead and do that. Now that the amplifier is connected, it is recommended that the firmware be updated. The firmware should be updated whenever new desktop software is downloaded to ensure that the desktop software and the firmware on the amplifier are compatible. If the PC has access to Google servers, the desktop software will download the latest compatible version of the firmware when performing the firmware update. In the desktop software, click on the Settings tab. Slide the toggle over to download the new firmware. Once the download is complete, the software will prompt you to restart the amplifier. Restart the amplifier. When the amplifier repowers back on, it will begin the firmware update process. The red and green lights on the front panel will flash. Once the update process is finished, the desktop software will restart. In the Settings tab, it will now show that you have the current version of the firmware. If, however, there is no access to the internet or you simply cannot contact Google servers, you can manually download the firmware from the PiezoDrive website. The desktop software can then be used to load this firmware. Once loaded, simply slide the update firmware toggle over and restart the device when prompted. The same update process will now be performed. Now that the firmware is up to date, let's have a look at the main control panel. It can be seen that there are many controls, and it is very difficult for a first-time user of this product to determine the correct values for all of these controls. For this reason, we developed an assistant, which can help determine a good starting point for the value of these controls. However, before we start using the assistant, it is recommended that you set the maximum load power to a safe level for your load. To start the assistant, simply click on the assistant button. Once you've ensured that the load is connected, press proceed. The assistant will then perform a frequency sweep from 15,000 Hz to 200,000 Hz. Once the frequency sweep is complete, you will be prompted to zoom over a resonance. You may need to consult your manufacturer to determine which resonance is the one that you need to track. Once the resonance is selected, the assistant will perform an additional frequency sweep at a higher resolution. Once this is complete, it will suggest two resonances that it can track, the series and the parallel. If you require more information on which resonance you need to track, please consult our website, as it has a full write-up of the pros and cons of both these resonances. The assistant will also estimate the maximum power delivered to the load for both these resonances. If this is less than expected, you may have mismatched the transformer for your load. If this is the case, please consult our team to organize a trade. Once a resonance is selected, the assistant will then show its recommended settings. If the track button is pressed, the assistant will then apply these settings to the controls panel and begin to track the resonance. Now that we have used the assistant to get some starting values for the controls, let's go over what the main controls do. Starting at the top, we can see the Enable slide toggle. This will enable the output from the amplifier. Below this, we then see the phase tracking slide toggle. When this is enabled, the phase tracking controller will be enabled on the amplifier. This controller will adjust the frequency until the measured phase and the set point phase are equal. When phase tracking is enabled, manual adjustment of the frequency is disabled. All controllers used by the amplifier are purely integral. The next slide toggle is for power tracking. The power tracking controller will adjust the voltage until the measured power and the power set point are equal. When power tracking is enabled, manual adjustment of the voltage is disabled. Below this is current tracking. When current tracking is enabled, the voltage will be adjusted until the measured current and the current set point are equal. When this is enabled, manual adjustment of the voltage is disabled. The next slide toggle is to disable and enable the remote control amplitude. This will only work when the remote control is connected and enabled. If current tracking or power tracking are enabled, the set points will be adjusted depending on the position of the remote control's dial. The next control adjusts the output voltage of the amplifier. The units used are volts peak to peak, and if current tracking or power tracking are enabled, this control will be disabled. The frequency control adjusts the output frequency of the amplifier. Input values are limited to the minimum and maximum frequency values of the amplifier. The units used for this control is Hertz. This control will be disabled if phase tracking is enabled. The minimum frequency control allows the user to adjust the minimum frequency of the amplifier. It is limited to a value between 5,450 Hz to the maximum value of the amplifier. The maximum frequency control allows the user to adjust the maximum frequency of the amplifier. It is limited to a value between the minimum frequency of the amplifier and 520,000 Hz. If phase tracking is enabled and the amplifier cannot lock to a resonance, the frequency will wrap between the minimum and maximum frequency. The phase set point allows the user to adjust the phase set point. This is the value that the phase tracking controller will try and match to. The phase control gain will adjust the amount that the controller will change each step. Low values will mean that the controller runs slowly. High values will increase the speed of the controller. However, higher values may lead to instabilities. The current set point allows the user to adjust the target value for the current controller. The current control gain will change the amount that the controller changes the voltage by each step. High values will increase the speed of the controller and low values will decrease it. High values may lead to instability. The power set point controller allows the user to adjust the target power for the power tracking controller. The power control gain changes the amount of voltage changed per step by the power controller. High values will increase the speed of the controller and low values will decrease it. High values may lead to instability. The maximum load power will allow the user to adjust the maximum power delivered by the amplifier to the load. If this value is exceeded, the amplifier will overload and disable the output. The Save button allows the user to save the current values to flash storage. These values will be restored on power reset. Now we understand what the controls do, let's have a look at the values that the assistant has assigned. We have asked the assistant to find values for the series resonance, which has an impedance of 16 ohms and occurs at approximately 61,000 Hz. For this load and transformer turns ratio combination, the maximum power delivered at this resonance will be 45 watts. This is significantly lower than the 210 watts the amplifier is capable of providing. This would indicate that the impedance of the transformer and the load are not well matched. The user can specify the target power for the load, and I have set this to 5 watts. As we can see, the assistant has suggested that the frequency be set to 60,821 Hz with a maximum frequency of 128,924 Hz and a minimum frequency of 31,211 Hz. As discussed before, if the amplifier cannot lock to a resonance, the frequency will wrap between the maximum and minimum frequency. The phase has been set to 0. This will occur if the assistant determines that the phase crosses 0 for a resonance. If no zero crossing is determined, the phase will be set to the phase where the minimum impedance occurs. The phase control gain has been given a positive value. This is important for tracking a series resonance. A negative value will allow you to track a parallel resonance. The value of 0.04 is quite low and will ensure stability. For a series resonance, it is recommended that current tracking be enabled. For more information about this, please read the write-up on our website. The assistant has determined that the current set point should be 800 milliamps. This is based on the series resonance impedance and the desired load power. We can see that the measured load power approximately matches the desired load power. Hopefully you have connected and correctly configured your amplifier. If you are struggling with any steps in this video, please reach out to PiezoDrive.